Hi, ladies and gentlemen. This is Mr. Green, and this is another in a series of articles of recordings for Algebra 2. I almost said geometry there because you know what? We're looking at almost a geometric thing this week. Really? Well, we're going to be looking in Unit 6, and you should be working on Unit 6 stuff and on Study Island stuff. Remember, due dates do have importance, so you need to make certain you're getting things done and not leaving any zeros out there. Okay? So we're going to look at transformation of points and figures. This is something you did in geometry. You transformed points and figures. You moved them around. We're going to show you how you can do this with Algebra 2 matrices. Okay? So, you could write the coordinates for a single point as a 2 by 1 matrix. Okay? You put the x, y just like this. X over y. Okay? And then put the first point in the first column and the second point in the second column. You put the points x in the first row and the y in the second row. So for example, this one would be -3, 2, 1, -1, and 4, 5. See how we just added these 3 points? I took the 3, -2 and put it here, 3, -2. I took the second point, 1, -1, 1, -1. I put the next one, 4, 5, 4, 5. That's how you would take these points and put them in here as coordinates into a matrix. How does that help us? Remember doing the scaling when we were having to expand and and contract different objects when we were using scale factors to do things? Well, a scale factor becomes a scalar that you can use, and you can multiply the coordinates times the scalar and get your new coordinates out. So it is really easy to do. This is a dilation. That's what we just did right here. We just dilated an object with this. Let me give you an example so that we can do it here. If I've got the vertices of a quadrilateral are at 2, negative, and I'm just going to write them down as a matrix so I don't even have to worry about it. -2, 3, 4, 2, 4, -1, and -3, -2. Cool. We've written them down. Now we're going to dilate it by a scale factor of 2. That means I'm going to multiply everything here by 2. So it's going to give me the points -4, 6, 8, 4, 8, -2, -6, -4. Ta-da. We just scaled it. Okay? Didn't seem that difficult to me. If you want to plot them out, you're welcome to plot them out on the graph and see what you come up with. You can stop it and look at where the points would be. Okay? What if instead of making a dilation, we wanted to scale them differently? We wanted to scale the x by one number and the y by another number. Then instead of using a scalar in front of it, we just put a matrix in front of it. We got the scale factor for the x and the scale factor for the y's, and zeros in the other two fields there, and we could actually scale something by different numbers. Let me show you what we're going to do here. We're going to have -4, 1, 2, 1, and 0, -3. Okay, and we're going to have different scale factors for my x and my y. So I'm going to do the horizontal by 1/2, 0.5, and I'm going to do the vertical by 3. So when I multiply these together, 1/2 times that one is going to give me a -2 plus 0, so that's going to be a -2. Okay, 1/2 times 2 is going to give me a 1, and 0 times 1 is going to give me still going to give me that 1. So that's going to give me a 0. Okay, this will be a 3, this will be a 3, and this will be a -9. I just scaled the vertically by 3 and horizontally by 1/2 by using this matrix here to multiply times this matrix here. Okay? It's really an easy process to go through and do that. Okay, what if I wanted to translate a point? we use translation in a slightly different way. See how this matrix is set up here where I've got ones on the horizontal, on the diagonal going across this way, right? This is my translation in the x direction. This is my translation in the y direction. And then I've just got my xy points that are sitting here. And what are we going to do? We're going to multiply them. And when we multiply them, we will get the translated figure. Okay? So what are we going to, let me look at this one here. My translation is going to be 1 0 0 0 1 0, and I'm going to translate the point 7 units to the right, so that's going to be 7, and 3 units down, -3 and a 1. And I'm going to be multiplying that by my xy point, which is at -2, 9. Okay? And I got to put a 1 down there at the bottom to make it work out so that I can multiply. Okay? 1 times -2 plus 7 times 1 gives me -5. I would say 7 to, yeah, -5. Okay? 9 times 9 plus -3 gives me a 6. And then this is going to give me a 1 there. There's my new point. -5, 6. Let's just check that real quickly. -5 and 6. Yes, that'd be right. Okay? That's where you have to go about doing the translation. Let me try one here. Okay, let's try one here. If we're going to translate, so we're going to be writing them down here. 1 0 0 0 1 0, and my translations are going to be 2 units left, that's -2, and 6 units up, 6 and a 1, and I'm going to be multiplying that times my matrices. It's going to be a -4, -1 1, -4, -3 1, 8 2 1. And what am I going to be left with when I get done? It'll be a 3 by 3 matrix when I get done. Okay? We're multiplying. So 1 times -4 is -4. -2 times 1 is -2. That's going to give me a -6. Doing the same thing for this next one is going to give me a -6. And this one is 8 and -2 is going to be a what is that? -4, -6. 4, -6. 4, -6. 8 be a 6, a positive 6. Sorry. Okay? Doing the second one here. I'm going to have -1 and 6 is a 5. And a -3 and a 6 is a 3. And a 2 and a 6 is an 8. And then I'll have 1s across the bottom. And my points are right there. Okay? Okay? To reflect a point, here's what's going to happen. If we're going to reflect across the x-axis, see how I've got the 1 and the -1 here? I'm taking the +1 and a -1. I'm going to multiply it times the xy's, and I'll get that -y. If I do the y-axis, -1, 1, -x, y. If I'm going across the xy axis, it's actually 0, 1, 1, 0. And it will actually reflect across the xy axis. This was always the hardest one to do if you were trying to do this in geometry. But if you try to do it here with this matrix math, it works out much easier to do. Okay? If we're trying to do something, a rotation, 90 degrees clockwise, see I've got the -1 and the 1 here? It'll actually create a y -x. That's a 90-degree clockwise rotation. A 90-degree counterclockwise positive and a negative. Gives you that negative y. That would be a 90 degrees counterclockwise. 180 degrees, you make them both negatives. Okay? Going on this diagonal, it makes them both negatives. That's a 180-degree rotation. These were always hard things to do in geometry and hard for us to figure out. Now, the interesting thing is, if we go to 3 dimensions, it works very similar to doing it in 2 dimensions. It just is a factor of taking it one more dimension out. Okay? And so it becomes much easier to do. So, what do we want to do? Let's see here. Let's do a reflection across the y-axis. If we want to reflect across the y-axis, we're going to use this -1, 0, 0, 1. So that's going to be a just like that. Okay? And our points that we're doing, -1, 8, -2, -3, 4, 3. Okay? And we're going to multiply these. What are we going to get? We're going to get a 1, 8. We're going to get a 2, -3. We're going to get a, oh, wait a second. I'm supposed to have been adding those. Sorry. Try again. -1 plus 8 would be a 7. -2 plus a -3 would be a -5. -4 plus 3 would be a -1. Okay? 8, -3, 3. We just reflected it across the y-axis. That didn't look right. I'm trying these top numbers again. Those are not right. Sorry. I just wasn't thinking when I was doing the multiplication. Distracted. -1 times -1 is a positive 1. -1 times -2 is a positive 2. Positive 2. -1 times 4 is a -4. That would be reflected across the y-axis. Okay? So, I'm sorry, distracted a little bit. So, a 90-degree rotation. And were we going clockwise or counterclockwise? Clockwise. Clockwise. It's going to be this one. 0, 1, -1, 0. So we're going to have a 0, 1, -1, 0. And we're going to multiply it times that same values there. -1, -2, 4, 8, -3, 3. When we multiply these out, we're going to get an 8, -3, 3, and we're going to get a 1, 2, -4. Those would be rotated across the 90-degree rotation. Okay? You can see how doing these rotations becomes easy if you're doing it with matrix math. Hopefully you do. So it is a relationship back to that geometry. So I appreciate the fact that when you guys have problems, you're sending me K-mails, you're talking to me, you're coming to tutoring. We're getting close to the end of the semester, so you need to make certain you get everything taken care of. Make certain you tell me you're in Algebra 2 if you send me any information, and I will talk to you next time.